All right, welcome back to the Punny Math Teacher. This is the last video in our equations unit. It's on literal equations. Remember, these are notes to your future self. Please rewatch them, rewind, go back and forth, go pause. Lots of pausing is definitely helpful, and where you can try it on your own and then look at the answer and check yourself. Please try these on your own. That's what they're there for, is self-checking, but that way you get the guidance afterward to make sure that you always remember the steps or the reasoning. Knowing the logic behind everything is going to help you way more than just memorizing steps. All right, so know why we're doing what we're doing. All right, and then just remember our final comprehension question at the end. Your goal is to write a brochure to answer our objective. So we've gone over proportions and dimensional analysis, percent of change with discounts and tax, and today we're on literal equations. So make a little section on each of the brochures, make an interactive Google Slides that's hyperlinked to everything, whatever you want to do, but make sure that it's something that you can access and that you actually will benefit from. Make it for a partner. Maybe they make one for you and you make one for them and you switch. And make sure that it's legible and they can understand exactly what you're saying and what steps and what's your logic and how you interpreted it, because everybody will interpret the math in a different way and process it a different way. Okay, so literal equations. We're on page 16. It's just one page. We're going to make a KWL chart and it'll be amazing. Yeah, because it's just, yeah, we're good. Okay, 16. I was almost there. Here we go. Literal equations. I'm gonna do blue and gray. So, literal equation. Sounds really scary, huh? But it's actually not. It literally isn't. Okay, literal equation is an equation, though we typically see these mostly used for formulas. Formula with mostly variables. We're not going to have a lot of like 2x plus 3 equals 12. It's mostly variables. An example is perimeter is equal to 2 times the length plus 2 times the width. That's for a rectangle. Or area, which is length times width for a rectangle. So notice how in the area one there are no numbers at all, but in the perimeter we do have some numbers for coefficients. There's 2 lengths and there's 2 widths, but we could actually avoid that if we wanted to put length plus width, and then we have only variables. So there's different ways of writing it. So we're gonna have a K, a W, and an L. The K is going to stand for what we already know. The W will be what we want to know, so more of the notesy section, and then the L is for what we learn, i.e. practice. So draw lines down your whole page. So 2 things that we know. We know that how to solve for x. So we know if we get x plus 2 equals 7, I want to make that 2 disappear, so I need to make it turn into a 0. So that turns into a 0. X equals 5. Woohoo! Our goal was to isolate x. Our goal was to isolate the x, or the variable in that sense. And then number 2, beefing it up a little bit. So if we have 2/3 x minus 4 equals 12, pause it, try it on your own. I know to add 4 to make that go to 0 for the additive identity, and then I want to make this go to 1 for the multiplicative identity, and that would be 8, so it's 24. Again, our goal was to isolate your variable, or isolate x in this case, because that was our variable. So we know how to isolate our variable. You've done a bunch of practice on this, hopefully, and not just watched all these videos in a row, but unless you're reviewing for a test, that'd be a great way to study, is just to rewatch the videos. And then you don't have to take notes extra, just read through your notes while we work on stuff. Okay, so now what we want to know is how to solve for x, but in a different context. So I want to solve for x in this equation, ax plus by equals c. X is not isolated. A variable is. Which variable? C. C is already isolated. X is not. How do I isolate the x? I need to get that x by itself. So, oh, actually, these are a practice. What we're learning is going on right-hand side. There we go. So our first step is going to be subtract by to both sides. So I'm going to move this constant, as in I'm going to make it go to 0. See, by minus by, that's still 0. Doesn't matter what b and y are. If you subtract them, they're going to go to 0. And now I'm going to get c minus by. You could put negative by plus c. That would work. All right. Now I want to divide by a to both sides. Notice that dividing by a is making that multiplicative identity of 1. A divided by a is 1. Notice that a gets divided by the whole thing. C gets it, negative by gets it, every single term on the right hand side gets that. So now I have x equals c minus by divided by a. And x is isolated. So this was our goal. In this case specifically, it's solving for x, so I isolated x specifically. But sometimes they don't want us to solve for x or get x by itself. Another example would be if they want to solve for length. I'm using a cursive L, so you can tell that it's not a 1 or an I. It is a cursive L, so notice that it is a cursive L. I'm going to start with perimeter equals 2 times length plus width. This is another way to write this equation up here. All right? So there's multiple ways to write that same formula, which is really cool. So I'm going to... Actually, I don't have to. You could distribute the 2, which is what I'm going to do, or you could divide by 2. I'm going to divide by 2. I want to divide by 2 to both sides. Because that makes 1. Okay? And now how do I get that length by itself? I'm going to subtract by w to both sides. Now notice I lined it up, but they're actually not like terms. So I have to keep them separate. Okay? Now, this is one way of writing it. If I had gone with the distribution that I originally was saying, your answer would have been p minus 2w over 2 equals length. Both of these are right. They're the exact same equation, they just look differently because we did different steps, but we still did legal steps. They weren't awkward. They still kept a balanced equation, and this one I could argue is more simplified because it doesn't have the extra 2 for the w term, but it still has a 2 in there, so, woo! Third, try this one on your own. Circumference equals 2 pi r, and you're solving for r. Get that radius by itself. You should end up with, boom. It's just division. That one extra step, that's it. Pi is not a variable. Pi is actually a number. So you do not have to treat it like a variable. Just know that it's actually a number. So this one has 2 numbers in it, 2 and pi. And there are 2 variables, circumference and radius. And we're done! Woo! Oh, there we go. And that means you can now finish your brochure. So you can make a digital brochure, make it in your notes. If you want, make it on one of your pages. And then you just have a page at the end of every unit that's a brochure that you can just, has foldable or has different tabs or is interactive or something. Make it a pop-up. So you can do so many things. Yay! And thank you for watching. We made it under 10 minutes. Woo! I'll stop it now though.